Hello, everyone, and welcome to today's event. Webinars are enhanced by your participation, so we encourage you to submit your questions throughout the presentation. Please use the Ask a Question button at any time. You may type your question there. All answers will be given verbally at the conclusion of the webinar. If you experience any audio issues during the webcast, please click on the Rate This button on the top of your player window and follow the instructions to receive help. If that does not resolve the issue, please email support@brighttalk.com and a customer support specialist will get back to you shortly. This event will be available on demand just a few minutes after the live event concludes. We invite you to view other upcoming events and on-demand content available in this event channel after the presentation. Today's speakers are Navneet Singh, Product Marketing Director, and Zoltan Diak, Senior Product Marketing Manager. Welcome, Navneet.
Thanks, Amanda. Thanks, everybody, for joining. Me and Zoltan have spent many years talking to customers like yourself, network security administrators, firewall administrators, and we recognize how valuable your time is and how many projects you have on your plate. So we really appreciate the time you took to join us on this webinar. So over the next 35 minutes or so, we're going to talk about three things. We're going to give you a brief idea of the market landscape about firewalls versus next-gen firewalls. We're going to spend the majority of time in the 10 things to test, and then we'll share more information. So as you know, in general, you use RFPs, you use evaluation criteria to test firewalls, and we will share 10 things that you must test as the market evolves to a next-gen firewall. So we both come from Palo Alto Networks, so obviously we also recognize that you have a choice of vendors today. You see a lot of different vendors having next-gen firewall capabilities, and so we want to share what we've heard from our customers. Again, this is a vendor-neutral view. What we've heard from our customers, what are the most important things that they should evaluate in the next-gen firewall that makes them successful over the long term. So in terms of the market landscape, the world is really moving to the next-gen firewall. If you haven't deployed next-gen firewall, you're probably in those group of enterprises or organizations that will transition from traditional firewalls to next-gen firewall within the next 2 years. And that data comes from Gartner's Magic Quadrant for the Enterprise Network Firewalls, which was published last year. And why is that happening? Because legacy port and protocol-based firewalls cannot determine things like applications, users, devices, things that are really required for you to enforce those business rules that your CIO or Chief Security Officer may be asking you to implement. And as the move to next-gen firewall is happening, buying of security has also changed. Traditionally, we've seen firewalls bought by networking team. You also see security operations in some cases buying the next-gen firewall. Traditionally, they used to buy anti-malware solutions and other security solutions while firewalls were bought by the networking team. But now, with next-gen firewalls, you have advanced malware capabilities on the next-gen firewall, and that's why security operations team is involved. The world is also moving to the cloud. Both public and private hybrid cloud is the reality, and we see a lot of customers buying next-gen firewalls not only for their on-premise data centers but also for their virtualized cloud environments, and they want to manage those firewalls from a single management console. So those teams that manage public and private cloud deployments are also involved. And then, as you know, with cloud adoption, a lot of times the application development team or the DevOps team manages those environments. And they many times manage some part of the security, if not all of the security. Many customers we talk about, they say the security teams, the centralized security teams, just publish guidelines. And they are actually followed by app dev teams or the DevOps teams. And so they are involved. they are a stakeholder in who will buy and operate the next-gen firewalls. So it is a team decision now. So that's changed, and we'll keep that in mind as we discuss the 10 things that you must test. Now, we really advocate testing the next-gen firewall before you buy it, and there are many reasons for that. You can take risks in some areas of your life, but we don't recommend just using the marketing collateral for buying or making the decision about the next-gen firewall, because it's a long-term investment. As we have discussed, it affects many stakeholders, and it also is the underpinning that will allow you to safely enable your business. So it is our customers want to drive profitability and growth while minimizing risk. Security is a boardroom level conversation. So because of all of those reasons, we really want you to be successful in deploying, maintaining your security and help enable your business. And that's why we really recommend testing the next-gen firewall before you buy it. And this is also a reminder that if you go to our website, paloaltonetworks.com, you will see this graphic, and if you click there, you'll actually be able to download the PDF version of the 10 things to test and the mistakes to avoid. So you will be able to get access to that from our website as well. So let's talk about the 10 things, and that's where we're going to spend majority of our time. I'll talk about some of the capabilities, and then I'll pass it on to Zoltan to talk about the remainder. Number one capability, this might be a little bit surprising for you. Traditionally, firewalls are not associated with preventing credential theft, but at the same time, if you look at Verizon Data Breach Investigation Report, you will see that 63% of the breaches they involved weak or stolen passwords. So with more than half the breaches involving passwords in terms of security, this is a topic that cannot be avoided. So this is one of the most prevalent ways, and so far there have been different piecemeal approaches to address it. What we recommend is that your firewall or next-gen firewall should be able to do certain number of things. It should be able to prevent the use of corporate credentials on unknown websites. It should also protect you from phishing, and it should block users from submitting corporate credentials. And it should be able to compare those credentials with the Active Directory without really storing a copy of the password on the next-gen firewall. So I will also give you an example of how we do it for each capability, but again, the capability itself is vendor neutral, and you should be able to evaluate this capability in any vendor that you shortlist. So what we do for preventing credential theft is that when a phishing email is sent, the link in the phishing email is analyzed by Wildfire, our advanced malware analysis service in the cloud, and it is blocked by PanDB, our URL filtering service. So a vast majority of the attacks are actually blocked here, so that John Doe is not even able to access any of the phishing websites. So there's no reason John will be able to lose credentials because he's not able to access those websites. But at the same time, we also know that the websites and the attackers are becoming more sophisticated. New websites are springing up every day. So it is possible that some new website has come up which John is somehow able to access. And in that case, what we do, and this is really important, is we are able to look at that network transaction, see that John is submitting corporate credentials. Because we have access to Active Directory for username and password, we are able to match those credentials and say these are corporate credentials, and there's no reason for corporate credentials to be submitted to a new website. And that's where we see that we are able to block the corporate credentials from being submitted. By the way, I do see a question about audio. If anybody else is having audio issues, please let us know in the Q&A window. So let's continue on. It is possible that the attackers are somehow able to get your password. So passwords today are available in the black market. In some cases, it's also possible that a huge leak happens on one of the social media websites, and maybe the user has used the same username and password on social media as on the corporate network. So attackers today may have access to your credentials in spite of you having the best technology that protects you. So then the attacker is able to impersonate a legitimate user and come in. So how do you protect that? The requirements are that in this situation, we must be able to use multi-factor authentication. Why? Because in that case, the user not only has to have access to your username and password, but also needs the second factor authentication, which in many cases is a phone, but could be another factor. And if the user doesn't have access to that, the access to that sensitive resource will be blocked. And the next-gen firewall should be able to do that with a variety of partners, because different organizations may already be using some multi-factor authentication solution like Okta or Ping Identity. And it should also be able to do it for any type of application, including older applications that are not multi-factor authentication enabled. So let's talk about how we do that. This is a kind of a continuation from the previous diagram where we mentioned we stop credentials from flowing out. But if the attacker already has those credentials, what we do is we allow you, the firewall administrator, to create a policy saying for all of my sensitive resources, let's say mail server, internet controller, ERP server, those sensitive applications cannot be accessed with only a username and password. The user must have a second factor of authentication. The great news is that now you don't need to enable each application. Typically, when we talk to customers, they tell us enabling each application for multi-factor authentication takes months. And that's what we have simplified. You can just create a policy which says these 10 or 20 or 24 applications are really sensitive. And with one click of a button, you can say enable multi-factor authentication. And then we talk to Okta or Ping or other partners to enforce multi-factor. So what does that mean in practice? For your users, it means that if the attacker has a username and password, tries to go to ERP server, the valid user will get a phone message saying, do you allow access to this? And the user may say reject because the user is not actually trying to access that application, the attacker is. And that's when the attacker is not able to access the application. But in addition to that, we also log that event. And if some of those events get logged, you as the firewall administrator can see those events and see that somebody is trying to access this application with stolen password, because the second factor of authentication is getting rejected again and again. So really powerful feature that you should evaluate in your next-gen firewall. Third, we talked about public and private clouds. In those environments, IP addresses change continuously. Workloads are virtualized, and you can't really create policies based on IP addresses. So the requirement is that you should be able to use your next-gen firewall to create consistent security policies, irrespective of IP address. And how do you do that? One great way to do that is to create security policies based on VM attributes of workloads. So if the application moves from one VM to another, or one physical server to another, and therefore the IP address changes, the VM attributes still remain the same, and so the same policy can be applied. So let me give you a more detailed example. So let's say that you have several compute resources here. So there are Windows environments, Linux servers, SharePoint hosted on those servers. Some of them are geographically distributed, some of them in London, and some of them in the US, and so on. And you've created policies on those servers. What we do is that we create the policy based on the VM attributes. And those attributes could be the geographical location, could be the type of application that is deployed. It could also be the operating system that's running. So those VM attributes combined can identify a particular workload. And once that workload moves from a physical IP address or physical server to another server, the same policy will still be applied because the attributes remain the same. And that's what you see here under PAN-OS security policy. The policy is applied based on those attributes. And so this is a really easy, nice way for you to implement security policies and avoid having to update them continuously as the IP addresses change. We know that in this increasingly complex environment where there are physical firewalls, there are virtual firewalls, you also have to manage maybe VPN devices on mobile devices. You really need to simplify management. You really need a management that has consistent policies and easy for you to operate and maintain. And that's what will keep the OpEx down. And that's why our requirements are that many customers start by using a single firewall or a set of firewalls and use the local device manager. And slowly over time, they update to using several firewalls. So as customers do this in this workflow or in this timeline sequence, there should be no change in kind of learning curve for the customer. And this can only be done if you have the same management interface locally as well as the central management console. Maybe there is some additional functionality, but the base user experience should not change as you move from a single firewall to multiple firewalls. You should also be able to roll back changes from specific users because many administrators administer the firewalls. And log management typically requires more resources, so sometimes you can dedicate some appliances for log management functionality. So you should be able to separate log management from code configuration, yet you should be able to use your management as a single pane of glass. So again, here's an example how we do it. Panorama is our central device manager. The important thing to remember is it manages all the devices, whether they are physical firewalls, virtual firewalls, small branch office firewalls, or the large data center-based chassis. They're all managed centrally from Panorama, which looks exactly the same as the local firewall management console. So there is no separate learning curve. You can have multiple administrators assign role-based access. And you can also use features like creating templates for, let's say you have an internet edge deployment. You can create a template that you can use for pushing out policy configuration to all the firewalls that may require internet edge policy. And once you deploy those policies, you can use device groups to manage groups of firewalls. Again, as I was saying, there could be one group of firewalls that are operating at internet edge, another group of firewalls that operate in your data center, and they require separate policies. So you can manage all of them with groups of devices, and the same configuration can apply. Now, I mentioned complexity earlier as well. We totally see our customers using the Next-Gen Firewall not in a silo, but as part of your entire security ecosystem. And you have workflows that span different devices. As an example, your wireless LAN controller may detect something, feed that information to the firewall. The firewall may detect something and say this particular user may be infected, or this machine may be infected, and so the wireless LAN controller must either quarantine it or put it in a separate LAN or a separate access. So you need your next-gen firewall to be able to consume information as well as send information and kick off workflows in your ecosystem so that it is easy for you to operate the security ecosystem. Another advantage of that is it takes care of processes that may be cumbersome, may be error-prone. It automates those processes, and so it's really reduces the number of errors, and also frees up more time for you to be able to spend on more high-value tasks. So the requirements for that is that there should be a completely programmable API set, a standard set of APIs that are exposed by the next-gen firewall that other devices can use. So that's for inbound messages. And for outbound, in the terms of next-gen firewall kicking off workflows, it should be able to work with any device that exposes a standard API. For example, you want to create a ticket on a ticketing system, or I give you an example of a wireless LAN controller. If those devices expose an API, your next-gen firewall should be able to communicate with those devices. And here's an example. Let's say that a new threat came in, and that threat is not yet a known threat, so that's why we don't have signatures for it. The threat goes to an endpoint, which, let's say, maybe it has our endpoint agent installed, which is Traps. And the administrator has turned off certain capabilities of Traps that would have prevented it from executing. So it is able to execute. So it's malware, it's able to execute. Now, because it's an unknown file, it was also sent to Wildfire, our analysis service in the cloud. We observe that malware in the cloud and know that it exhibits certain sets of behavior. We see similar set of behavior from Traps, from the endpoint. We correlate that automatically and see that because there is similar behavior, this endpoint must be infected. That advanced correlation happens in Panorama, which is our central management console. And once we determine that this endpoint must be infected, we flow automated actions to the next-gen firewall. So the next-gen firewall can say, any device that exhibits this kind of behavior, you should tag that device with something like compromised host. And a dynamic policy can be applied to that host. That dynamic policy could be enforce multi-factor authentication whenever this device tries to access a sensitive resource. So you've protected your sensitive resources without really quarantining the host. And at the same time, if you see the bottom right part of this slide, we also communicate with an ecosystem of partners. You could also say, create a ticket on ServiceNow that this action was taken, so that when this user calls in, we know that this host was quarantined because of for this reason. So all of these are automated actions, and we operate through standard APIs. And now we should talk about the applications and users that are distributed everywhere. So we talked about public and private cloud, but also users could be distributed in or outside your enterprise. The applications could be distributed, as I mentioned, they may not always be in your data center. So the requirements are to really provide consistent security and be able to use physical and virtual firewalls so that you can support an always-on connection to be able to access applications. And in some cases, You could also utilize the cloud to bring protection closer to the user. And let me give you some examples to show you how that works. So one, we have the Global Protect client, which is the client that resides on mobile devices, laptops, which will enable your users to always be connected to your data center, always be able to access the applications that they need, and yet get all the security that you. In addition to that, we also recently launched Global Protect Cloud Service. What this means is that if there are remote workers or remote branches where you don't want to have a physical firewall for a VPN connection, what you can do is you can enable those remote users and branches to utilize cloud-based Global Protect Cloud Service. And all the traffic goes to the cloud-based service, and we host that service in the public cloud for you. So you don't need to maintain the infrastructure. If you tell us we have 1,000 users or 2,000 or 10,000 users, we will scale up the infrastructure as required to support those users and branches. And what you are doing is you are maintaining and managing the policy that should be applied to those users and branches. So with that, I will turn it over to Zoltan.
All right, thanks, Navneet. The next thing we want to talk about when evaluating an NGFW is the ability to take advantage of automation to address really the rapid pace of today's threats. So it's no secret that today's attackers, for the most part, aren't just sitting there and launching one-off attacks. Attacks are automated and moving at machine speed. Every day, security teams are up against advanced persistent threats driven by automated bots. And humans just aren't capable of keeping up with the sheer volume of threats that come in. They have to sift through data and security events happening across an entire organization and prioritize those events, identify, and then respond to them. It's a process that just doesn't scale. So we have to fight automation with automation. In order to move fast enough to stop attacks, security services need to be automated to identify the attack, create and distribute protections, and then work with other parts of your security architecture. So known threats have to be blocked without degrading firewall performance and hurting business productivity. New threats also need to be identified and protections automatically generated and implemented across all technologies for consistent protection across the organization. Automated tools should also be able to identify patterns and correlate data to ID hosts on your network that may be exhibiting malicious behavior. And of course, the more this kind of threat intel can be crowdsourced and shared at machine speed, the better protection for everyone. In this diagram, we show different opportunities for us to prevent attacks during the attack lifecycle. And at Palo Alto Networks, we've built automation into each of these areas. In the interest of time, I'll just point out a couple of examples very quickly. So at point number one, vulnerability exploits can be prevented by exploit signatures that are automatically updated in the NGFW as part of the threat prevention capabilities, or by preventing users from accessing malicious or unknown URLs that come from our URL filtering solution. At point number four, the installation of any downloaded malware can be prevented by our endpoint solution, Traps, in combination with signatures automatically generated through our dynamic analysis environment, Wildfire. And at point number five, even if it was completely unknown, it was a completely unknown malware sample, Wildfire will analyze it and allow us to prevent C2 traffic via URL filtering, DNS signatures, and sinkholing. So we also automatically create payload-based C2 signatures where we leverage the C2 payloads we extract from all of the malicious samples we collect in Wildfire and analyze them to find clusters and patterns in the outbound communications patterns. So we then create those C2 signatures that are vetted for false positives to ensure that we have high quality protection. And again, that all happens automatically, giving us researcher grade C2 protections at machine speed. So automation is built into each and every single one of these processes to ensure that we're moving at the speed we need to keep our security posture as strong as it can be. So besides being automated, most modern day malware also uses a variety of evasive techniques. For example, wrapping malicious payloads into legitimate files, packing files to avoid detection, or extending sleep calls to wait out potential sandbox environments. And with those virtual sandbox environments becoming more ubiquitous, attackers have adjusted by developing techniques and tools specifically geared to evade them. While we can't build individual tools to detect every piece of evasive malware individually, it's critical to utilize systems that can identify evasion techniques and automatically take action to counter them. Some of the ways we can protect against these evasions are by using multiple analysis techniques across multiple file types and versions, and by taking away some of the ways evasions work. So what you're looking at here is a screenshot of a typical malware generation protection tool. You can see it offers specific evasions for sandboxes like ThreatTrack and Panda, for hypervisors like VMware and Zen, and of course for virtualization in general, regardless of the tech used. And this is all available for purchase on the dark web, so easy for attackers to get their hands on something like this. Evasive malware is going to actively scan to determine whether or not it's being analyzed by anti-malware systems, and then the primary method to do this is by scanning the environment it's in to determine whether or not it's in a sandbox or virtual environment. So there are a number of ways it can do this. So for example, checking for user activity by clicking buttons, mouse movement, or typing speed. Lack of user activity is a sign of a fake environment, or unrealistic user activity like typing with inhuman speed. Environmental details or system config, so username or screen resolution, free disk space or number of CPU cores. These are all indicators of specific virtualization or emulation technologies. So if the malware determines it's in a virtual environment, it won't execute in an attempt to avoid detection so it can be submitted back into your network. So how do we protect against something like that? So first, we built our own custom analysis environment from the ground up. While open source in general is great, it isn't necessarily the right choice for threat analysis, because the source code is available to everyone, and that gives attackers a huge advantage. So we're not using open source components or proprietary software that attackers have access to. It has real hardware configurations and user environments, and in that way, our environment is designed to be a lot harder for attackers to be able to detect. Second, we use multiple analysis techniques. Static and dynamic analysis that's augmented by machine learning as a baseline for analyzing unknown files. So in reality, all three techniques have their strengths and weaknesses. Pure sandboxing can be great for detecting zero-day malware, but it's pretty susceptible to execution failures or disabled command and control. Static analysis and machine learning can be great for finding variants of known malware, but aren't great at detecting entirely new, never before seen malware. So rather than relying on a single approach, our Wildfire service leverages all three: static and dynamic analysis as well as machine learning. In addition, we also use bare metal analysis. So the concept behind bare metal is simple. If a sample examines its environment during analysis or exhibits any activity that's associated with VM evasion techniques, we kick it to bare metal and analyze it again, this time on real hardware. So if a sample is querying the BIOS or surveying the hardware config, or it's attempting to ID known hypervisors, among other activities, it's sent to bare metal, which is a real hardware environment that is, by its nature, immune to direct VM evasion and very resistant to environment-based checks. Switching gears a bit from countering evasive and unknown threats, we of course also want to know about as many threats as possible. Frankly, it's easier to stop them when they're known. So the more we know, the better, right? And that's where utilizing threat intelligence comes into play, and simply importing basic rules and policies just isn't enough. Most of our customers today leverage or consume intelligence or third-party threat feeds from a number of sources. Today in their environment, there's a huge gap in terms of how they can leverage them. If you want to consume and leverage them in your edge gateway, for example, you've got a lot of manual work. That means ingesting the feed. There's probably a process you have to look at. You have to look at it and federate it against other data sources, and then ultimately make it consumable by whatever platform you're using. And the more data you ingest, the more you can improve your risk posture, but that pile of data alone isn't really actionable. In order to achieve that desired outcome of preventing cyber attacks, organizations have to be able to action on collected indicators of compromise, automatically transforming them into prevention-based controls for enforcement on security devices. To that end, we also offer broad support for pulling in that third-party data, for example, through STIX and TAXI. We offer external dynamic list support. We've also developed an open-sourced tool called MindMeld. So MindMeld streamlines the aggregation, enforcement, and sharing of threat intel. It will ingest indicators from public threat intel feeds, private feeds, proprietary threat intel platforms, and what it does is produce curated feeds ready for consumption by your network enforcers and endpoint systems. So MindMeld essentially takes that massive data from threat feeds, aggregates it, correlates IOCs, and brings context such as priority and relevance of a newly identified threat, and enforces new prevention controls, including things like IP blacklists, for example. So it's a great example of taking raw data and getting the most out of it by turning it into valuable intelligence that can automatically improve your security posture to help stop attackers from successfully completing that attack life cycle. Finally, number 10, I'm sure you're all aware of some of the recent high-profile ransomware attacks that are occupying headlines on a regular basis. Ransomware attacks are damaging not only in terms of actual payments, but the lost productivity and lost data and harm to brand. As well, we're starting to see more instances where ransomware is more of a diversionary tactic to set up lateral movement where the goals might be assets or something other than pure ransom. And of course, there's no silver bullets in prevention, but beyond some of the basic techniques in trying to prevent ransomware from intruding into your network, there are a few things we think your NGFW should be able to do to stop ransomware. And really, this all draws from what we've been discussing throughout our time here today. Automatically blocking files to reduce your attack surface, integrating with threat intel sources to have as much access to actionable intelligence and IOCs as possible, and automating that entire process. There are multiple opportunities in an attack lifecycle to stop a ransomware attack, and the capabilities we've talked about here help you maximize those opportunities. So I thought the best way to illustrate this would be to quickly walk through an actual attack and how our NGFW and security services work together to automatically and preemptively protect our customers from it. So here we look at WannaCryptor, which impacted systems worldwide. I'm not going to talk about how WannaCryptor works, but rather focus on how our next generation security platform protected our customers through multiple complementary prevention techniques. Even before WannaCry hit, our customers were protected through several methods. First, traps. Our advanced endpoint agent used a capability called local analysis that was able to prevent WannaCryptor from being delivered to your system, even back in August of 2016. Threat prevention. Our threat prevention subscription provides inline vulnerability protection and IPS signatures, and these were automatically updated in the NGFW in advance to protect the vulnerability months before WannaCry 2.0 even hit. So fast forward to May 12th, when the attack became widespread. Our wildfire analysis service sees data from over 20,000 customers, plus third-party data services, and from our own threat research team, Unit 42, and automatically determines the maliciousness of those never-before-seen samples. So Wildfire had seen a sample of WannaCryptor and correctly determined as of 2:30 a.m. that day that it was malicious. So in as quickly as 5 minutes, Wildfire generated a prevention signature and pushed that out to all Wildfire NGFW subscribers. So our inline AV protection also released 2 AV SIGs for protection in excess of the already existing vulnerability protection that was in place. So customers were protected by traps, our threat prevention subscriptions, and Wildfire, all with no human intervention in there. So in addition, URL filtering monitors malicious URLs used and will enforce protections if needed, and DNS sinkholing could be used to identify infected hosts on the network. And while all that protection is great, you shouldn't be happy just stopping there. We know attackers may slightly change payload to evade existing protections, and because Wildfire is out there constantly looking for new samples and generating automated preventions that are deployed on your network via your NGFW, as well as through our endpoint agent traps. So that's a very quick example how your NGFW can leverage advanced security services to go above and beyond simple blocking and policy enforcement and protect you against advanced threats like ransomware. So with that, I'm going to turn it right back over to Navneet.
Thanks, Olson. So we wanted to wrap up this also with the mistakes that sometimes customers make while evaluating Next-Gen Firewall. And this again came from a lot of our conversations with the customers where we talk to them about the 10 things to test. One is incorrectly sizing the firewall. And there are several reasons for this. One of the biggest reasons is not paying attention to how the firewall datasheet performance was measured. Many times vendors publish raw throughput, and as soon as you enable any application level features, the throughput drops like 1/3. So paying attention to throughput that has application enabled and threat prevention enabled, all the security capabilities should be enabled. That's the throughput you want to look at. Plus, we always encourage customers to do testing in their own environment, and sometimes vendors like we do help customers come to our proof of concept lab. We call them POC labs. You can run performance tests here with your own traffic mix. Another important point to keep in mind is decryption. More than half the traffic is encrypted today. Gartner says that by 2019, 80% of the traffic will be encrypted. So keep that in mind. How much performance can you get from your vendor with decryption enabled? Talk to your SE, talk to the sales team to make sure that you have that information. Second, choosing a firewall in a silo. As we said, the firewall operates with your security ecosystem. Make sure that it has open APIs to communicate back and forth with other pieces in the security ecosystem. Sometimes you need some capabilities and the vendor says this is roadmapped. So what we've heard from customers again and again is trust what you can test and buy based on that. Ease of integration and scalability sometimes can become the biggest challenge, even if the firewall operates well. So again, goes back to the point about ecosystem. Make sure that it can integrate into your ecosystem well, and it can scale both in the cloud environments as well as on-premise. As your business needs grow, it is able to scale. The last is choosing a firewall with a steep learning curve, minimal support. So some of these things are, again, beyond the testing, just your experience of users. How easily are you able to maintain policies? If some firewall administrator leaves your organization, how easy would it be for a new person to come in and pick up the policies? How easy is the customers or the vendor support system? How responsive was their support during your evaluation phase? All of that should also be factored in when you make the purchasing decision. So that's all we had in terms of the 10 things to test. We covered 5 mistakes that customers often make. Now let's take a look at some of the questions that you've sent. So I see. Sorry, go ahead.
Navneet, just as a reminder for the audience, if you have a question, please use the Ask a Question button, and Navneet will read them to the audience.
Thanks, Amanda. I have a couple of questions here in Zoltan, then you can also take a look if there are some questions in your areas. So the first question is, what partners do you support for multi-factor authentication? Again, this is a feature that I covered in the beginning. We support Ping, Okta, RSA. We support Duo Security as well. And the important thing to remember is we have an open set of APIs that we can support other providers as well that can use that API. So what I'm going to do is I'm going to paste a link here under attachments and links. Okay, I'm not sure how to paste that. So maybe I can share that with you, Amanda, and we can see how we can paste the links here. But there is, if you go to our website and look for credential theft prevention, maybe you do a search, you will see a page on credential theft prevention. There's a white paper that details all our integrations and our partnerships. So feel free to take a look at that on our website. The next question is about how do you correlate logs from endpoints and next-gen firewalls? So again, this is a feature I covered under Panorama Centralized Management. So it is not only able to correlate logs from the next-gen firewall, but also from Traps, which is our endpoint protection agent. So Panorama gets logs from both Traps and next-gen firewall, starting our 8.0 PanOS 8.0 release, which was our latest release last year. And again, if you go search for the PanOS Administrator's Guide, you will see and look at all the new features under PanOS 8.0. You'll see the Panorama features, and one of them will be correlation of logs. So the correlation is done by the correlation engine in Panorama, and you can get more information on our website. The third question is, does the VM series autoscale in the cloud? So again, the person is referring to VM series are virtualized firewalls in the cloud. So VM series can be deployed both public and private cloud. And yes, it does autoscale. So we support the native autoscaling as an example in AWS. Again, if you go to our website and look for VM series autoscaling, maybe do a search, you'll see the information, including a light board that shows how autoscaling is done by VM series. Again, the intent here is that as your traffic grows, as applications grow in the cloud, you should be able to auto-scale VM series deployments so that your workloads are protected. So these are the questions that I see in my area. Anything else, Zoltan?
Yeah, so we have one question here that says, you talked about payload-based C2 signatures. What does that mean and why is it important? So let me take a step back. So there are generally two ways that we try to control C2 activity through signatures today. One is automated C2 coverage, and that's where C2 signatures are created that are based on domain, URL, or IPs today. And those can be done, most vendors do this automatically. The challenge there is that attackers and malware authors can create C2 communications that change the resulting DNS or specific URLs very quickly. So those signatures are quickly out of date, but we can produce them at volume, right, at scale. The other way is manually created payload-based C2 coverage. So this is where an actual threat researcher takes apart a malware sample, remote access Trojan, ransomware, and manually looks for signaturable parts of the outbound communication. So the payload of that communication, if you will. And payload-based communications don't change as often as something like DNS, but finding the similar parts to key off of can take a long time, right? It's a manually based effort. And the effort to create just a single C2 signature can be very resource intensive and may not cover many samples or variants. It just doesn't scale and isn't very effective, it's not very efficient. So what we do is automatically create those payload-based C2 signatures. So that's where we think we're different than any other vendors out there, right? So we have the ability to go in and automatically analyze all the samples we're seeing within Wildfire and create payload-based C2 signatures at scale. So that's really the difference there, and that's really important, is that that gives you much broader coverage at a much higher quality when you're looking at your C2 signatures and protection against command and control. So that's it on the questions that I'm seeing from my side. Anything else we want to cover before we wrap up here?
No, I think that's all. Again, thank you a lot for attending. We value your time. And again, as a reminder, you can go to our website and download the papers for the 10 things to test in your Next-Gen Firewall, as well as the 5 mistakes to avoid. Thank you for your time. We'll now close the webinar.